You know, when we think about taking medicine, we almost always picture a pharmacy,
Right.
like a highly controlled, really sterile environment.
Yeah, definitely. Everything is perfectly measured out.
Exactly. You get a little plastic bottle, and inside is a pill with an exact milligram count. 10 milligrams of this chemical, 20 milligrams of that one.
Right. Very.
It's highly precise. It targets a very specific receptor in your body to fix a very specific problem. But then when we think about exercise, we tend to, we just lose all that precision.
Oh, completely. We just think about sweat.
Right, sweating, burning calories.
Yeah.
It's viewed as this blunt thing, like a sledgehammer approach to health.
The cultural paradigm really is just, move more, eat less. We treat physical movement as a generic catch-all pill.
Yeah.
You just take the pill, burn some energy, and hopefully you get healthier. We rarely stop to consider the exact chemical cascade that different types of movements trigger within our cells.
Which is wild.
Yeah.
But today we are throwing that sledgehammer away. We're bringing out the microscope.
I love that.
Because it turns out the specific type of exercise you do is just as precise, chemically speaking, as the pills a doctor might prescribe for you.
It really is. It's fascinating.
And to get that absolute scientific clarity, we're pulling from a brilliant 2024 study. It's called a randomized controlled trial to determine the impact of resistance training versus aerobic training on the management of FGF-21 and related physiological variables in obese men with type 2 diabetes mellitus.
Got the title.
Right. But so important. It was authored by Yimei Duan and Guotian, published in the Journal of Sports Science and Medicine.
It is a phenomenal piece of literature. Our mission today with this deep dive is to look at exercise through the exact lens those authors used.
Not just as a way to burn off a heavy lunch.
Exactly. But as a highly specific, targeted medical intervention, we're going to examine the underlying mechanisms, the exact ways that, lifting weights versus running on a treadmill alter the chemical environment of the human body.
And I want to speak directly to you listening right now. Whether you're actively managing a metabolic condition of your own, or whether you're trying to intelligently structure your weekly workout routine, or even if you're just insanely curious about the hidden mechanics of human physiology.
Which we all should be.
Right. This deep dive is going to completely change how you view your time in the gym. So let's set the stage.
Let's do it.
Let's look at the parameters of this study, because who they studied is just as important as the biological mechanisms they uncovered.
Absolutely. The study design is incredibly robust, primarily because of the specific population they chose.
Right.
They recruited 36 men. These were sedentary, obese men between the ages of 40 and 45.
Okay.
They all had type 2 diabetes. And crucially, they had been dealing with it for at least 4 years, relying solely on a medication called metformin to manage their condition.
Let's talk about what that actually means for a person's daily life, because we weren't talking about 20-year-old college athletes tweaking their routines here.
No, not at all.
We're looking at a population whose metabolic systems are already highly compromised. After 4 years of type 2 diabetes, your body is incredibly resistant to metabolic change.
That metabolic resistance is the core issue, and it highlights why the control group in the study is so important.
Because they stayed on the metformin.
Right. Metformin is a foundational medication for type 2 diabetes. Its primary job is to suppress the liver from producing too much glucose.
Okay, so it essentially lowers the ceiling on your blood sugar.
Exactly. But it doesn't necessarily force your muscle cells to become better at absorbing and using that sugar.
Ah, I see.
It manages the symptom, but it doesn't entirely fix the broken cellular machinery.
Right, so the men in the control group just kept taking their metformin and stayed sedentary. And predictably, their baseline health barely shifted over the course of the study.
Right, no real change.
But the researchers took the rest of the men and split them into two active groups. A resistance training group doing things like leg presses and bench presses, and an aerobic training group doing continuous running.
The intervention lasted for 12 weeks.
3 days a week, right?
Yep, 3 days a week in the late afternoon for about 60 to 70 minutes a session.
Now, the dosing of the exercise is the critical variable here, isn't it?
It really is. Both the weights and the cardio were strictly kept at a moderate intensity. The researchers specifically locked them in at 70 to 75% of their maximal heart rate.
Which is huge, because anyone who has ever tried to start a gym habit on January 1st knows the dropout rate is usually massive.
Oh, yeah. Usually within weeks.
People go too hard, they get hurt, they get exhausted, and they quit. The fact that a group of previously sedentary men with serious health complications had a 100% completion rate tells us something vital.
It really does. Every single person finished the 12 weeks and there were 0 injuries.
0. That's amazing.
It proves that a highly sustainable, moderate protocol is entirely achievable and safe. You do not need to push your body to the absolute limit to trigger a clinical response.
You don't need to be crawling out of the gym.
Exactly. The 70 to 75% heart rate zone is enough to signal the body to adapt without creating an overwhelming stress response that leads to injury or burnout.
Okay, let's unpack this. If FGF-21 is the target biomarker the researchers were tracking, we need to understand what this protein actually does.
Fibroblast growth factor 21.
Right. From my understanding of the research, this is the star of the show.
It absolutely is. From a physiological standpoint, FGF-21 is what we call a circulating hepatokine.
Hepato meaning liver, right.
Correct. It's a protein secreted primarily by the liver that travels throughout the entire bloodstream. And its job is monumental.
What does it do?
It acts as a master regulator for insulin sensitivity, lipid metabolism, and glucose homeostasis.
Okay.
In people with metabolic disorders like type 2 diabetes, the body loses its ability to efficiently clear sugar from the blood.
Yes, just builds up.
Right. So FGF-21 is a primary therapeutic target because it possesses this incredible ability to help human cells take up glucose.
Let's visualize this because the mechanism is fascinating.
Yeah,
Think of FGF-21 as a microscopic traffic cop sitting in your bloodstream.
I like that analogy.
Right. When you eat a meal, glucose floods into the blood. In a healthy person, the muscles eagerly absorb that glucose for energy.
The doors are open.
Exactly. But in a diabetic person with high insulin resistance, the muscle cells are stubbornly ignoring the glucose. The doors are locked.
So the sugar just piles up.
It piles up in the bloodstream, causing a massive traffic jam, which we see as high blood sugar. This traffic cop, FGF-21, steps in to aggressively direct that glucose traffic out of the blood and into the muscle cells where it can actually be burned.
And to take that traffic cop analogy one step further into the cell, we can look at how FGF-21 actually gets those doors unlocked.
Okay, how does it do it?
It works by upregulating a specific protein called GLUT4.
GLUT4?
Yeah, GLUT4 is a glucose transporter. When FGF-21 gives the signal, GLUT4 physically moves from the inside of the muscle cell up to the surface.
Wow. It physically moves.
It acts as the biological door, opening up to shuttle the glucose from the bloodstream into the cell.
Okay, so the central question of Duan and Lu's research was, how do different types of mechanical movement affect this microscopic traffic cop?
Exactly.
And looking at the data for the resistance training group, the weightlifters who were on the machines doing leg presses, knee extensions using dumbbells, they saw massive, highly significant adaptive responses in their glucose metabolism.
The statistics show a much greater drop in fasting blood sugar for that group.
And crucially, they saw a much greater drop in their HOMA-IR score. Now, HOMA-IR essentially calculates how hard your pancreas is working just to keep things normal, right?
Yes.
It measures the severity of your insulin resistance.
That is exactly how it functions. HOMA-IR compares your fasting insulin to your fasting glucose to determine how resistant your cells are.
And the lifting group saw a big drop.
A dramatic improvement in that score. And directly answering the researchers' hypothesis, this group experienced a significantly larger boost in circulating FGF-21 levels compared to the aerobic group.
So purely mechanical lifting, like putting heavy metal in your hands and moving it against gravity, literally multiplied the number of traffic cops on duty in the bloodstream.
It did, but the biochemical changes went far beyond just glucose. The researchers also measured the hormonal shifts in these men.
Right.
Over the 12 weeks, the weightlifting group saw their resting testosterone levels significantly increase.
Which makes sense for building muscle.
Right, but at the same time, their resting cortisol levels, which is the body's primary stress hormone, significantly decreased.
Wait, I have to push back on the logic of that. Lifting heavy weights is, by definition, an extreme physical stressor.
It is.
You are putting the body under intense mechanical tension. You're literally causing micro tears in the muscle fibers. How does putting the body under severe mechanical stress result in lowering a stress hormone like cortisol?
It seems counterintuitive at first glance. You are entirely correct that in the acute phase, during the actual 60 minutes of lifting, cortisol spikes.
Right, your body is freaking out.
Exactly. It recognizes the heavy mechanical load as a physical threat and triggers an immediate stress response to cope with it. But the study tracks chronic, long-term adaptations.
Ah, okay, over the 12 weeks.
Yes. The source material outlines a mechanism where repeated exposure to this specific mechanical stress triggers a downregulation of the glucocorticoid receptors in the adrenal gland over time.
So the body basically mutes its own panic button because it's getting used to the stimulus.
Mm-hmm.
The adrenal gland stops overreacting to the daily load.
That's a perfect way to phrase it. The baseline fundamentally shifts. The adrenal gland dials back its overall resting cortisol production.
That's wild.
Simultaneously, the muscle damage from the resistance training stimulates the production of anabolic hormones like testosterone to repair the tissue.
So you're shifting the body's entire systemic environment.
Exactly. From a catabolic state, which is a state of breaking down tissue, very common in poorly managed diabetes, into an anabolic state, which is a state of building and repairing.
And this ties right back to our traffic cop.
It does. The resistance training induces FGF-21 activation, and that activation actually increases the oxidative capacity of the muscle fibers themselves. The muscles physically change to become more efficient engines for burning fuel.
But fixing the muscle's ability to absorb sugar and repairing the insulin receptors is only half the battle for someone with metabolic syndrome, right?
Right.
The other half is the lipid profile, the fat clogging the bloodstream. And looking at the data, lifting weights barely touch that problem.
That's where we have to look at the continuous running group to see the second half of the picture. We cannot discount the treadmill.
So what does this all mean? Should we all just throw away our running shoes and only lift weights?
Not at all.
Because the data for the aerobic training group is completely inverted. While the weightlisters were doing episodic sets on the machines, the aerobic group was running continuously on a treadmill at that same 70 to 75% max heart rate.
Right.
And they didn't get the same massive blood sugar benefits, but their lipid panels plummeted.
The researchers recorded significantly greater drops in total cholesterol, a massive drop in triglycerides, and a superior reduction in LDL, which is the bad cholesterol.
And a better increase in HDL, the good cholesterol. Unsurprisingly, their VO2 peak, their maximal oxygen uptake, also improved far more than the lifting group.
Yeah, their aerobic capacity soared.
But why is continuous movement better at burning fat in the blood than heavy lifting?
The underlying mechanism comes down to the constant, unbroken demand for energy. When you are lifting weights, you might do a set of leg presses for 40 seconds, and then you rest for 2 minutes.
Right, you catch your breath.
And during that short burst, your body relies heavily on anaerobic pathways, using readily available glucose stored in the muscle for quick power.
Okay.
But continuous aerobic running forces your body to constantly engage cellular oxidative metabolic pathways. You are asking your body to produce a steady, uninterrupted supply of energy for 40 minutes straight without a single break.
Let's break down how the body actually accomplishes that. It realizes it is going to run out of quick glucose. So what happens at the cellular level?
To survive that continuous energy demand, the body has to upregulate the expression of certain messenger RNAs in the muscle and adipose tissue.
So the messenger RNA acts like a new cellular blueprint. The running is basically sending a signal saying, we cannot sustain this output on sugar alone. We need to switch our fuel source to fat right now.
Exactly. That new blueprint physically alters the enzymatic pathways. It forces the body to tap into stored fat and the circulating lipids in the bloodstream, utilizing them as its primary slow-burning fuel source.
Oh, wow.
Because the aerobic movement doesn't give the body a rest period to recover its glucose stores, clearing out the lipids becomes a biological necessity to keep the legs moving.
If we map this out, resistance training is like a system reboot.
Right.
It fixes the software.
I love that. Yes.
It repairs the hormones, it repairs the insulin receptors, it puts more FGF-21 traffic cops on the street to force the sugar into the cells. But aerobic training is like a slow-burning furnace.
Very different mechanism.
It just continuously, relentlessly melts down the structural fat and the lipids clogging up the blood vessels because it desperately needs that fuel to keep the furnace burning.
The continuous nature of the aerobic conditioning is exactly what makes it so potent for lipid clearance. The biochemical adaptations are entirely distinct because the mechanical stress, continuous versus episodic, is entirely distinct.
Here's where it gets really interesting, at least for me. The biggest takeaway from this entire paper isn't that one workout is mathematically superior to the other.
No, definitely not.
It's that exercise is incredibly specific. It's not a monolith.
The practical application of Duan and Liu's research is profound. Historically, a doctor might look at a patient with metabolic syndrome and give a blanket prescription like, you need to exercise 30 minutes a day.
Or just go sweat.
But this study proves that exercise should be prescribed with the same exact precision as pharmaceuticals, based entirely on an individual's specific blood work.
Yes. If you go to the doctor and your blood panel shows that your primary struggle is glucose homeostasis, like your fasting blood sugars through the roof, your HOMA-IR shows severe insulin resistance.
Then according to this data, resistance training needs to be your primary intervention. You need to be under the iron to trigger that FGF-21 release and fix the insulin receptors.
But conversely, if your glucose isn't terrible, but your lipid profile is a disaster, high triglycerides and high LDL cholesterol, then putting you on a bench press is not the optimal first step.
Exactly. Your most potent weapon is aerobic training. You need that continuous oxidative furnace to clear the lipids from your bloodstream.
And to you, the listener, this is where the power shifts into your hands. Understanding the mechanisms behind why you're choosing a treadmill over a dumbbell or vice versa allows you to target your body's specific metabolic needs rather than just guessing.
You're not just spinning your wheels anymore.
You aren't just going to the gym to sweat. You are going to the gym to execute a targeted chemical intervention. You are intentionally manipulating your own hepatokines.
You're forcing your adrenal glands to downregulate stress receptors.
You're physically altering your biology with total intention.
It is a profoundly empowering way to view physical exertion. It removes the vague, heavy guilt of feeling like you should just work out more, and replaces it with a strategic, evidence-based plan for your specific physiological architecture.
It really is. And it leaves me with this final futuristic thought to mull over.
Ooh, let's hear it.
The study specifically mentions that future research needs to look at a broader array of resting hepatokines and other muscle-based proteins. So if just 12 weeks of specific mechanical movements can fundamentally alter our genetic expression, our hormone receptors, and our blood chemistry to this degree, could we one day see a future where you wake up, your smartwatch reads your resting blood markers through your skin, and it custom generates a specific to-the-minute daily workout?
That would be incredible.
Right. Imagine your watch saying, "Good morning. Your triglycerides are elevated today, but your glucose is stable. Your prescription for today is exactly 24 minutes of aerobic training and 8 minutes of resistance training, perfectly balancing your precise chemical state for that exact day."
The science is certainly pointing in that direction. The precision we apply to medication will inevitably be applied to movement.
Absolutely.
And for those who want to understand the deep biochemical pathways that will make that future possible, I highly encourage you to seek out and read the full original article.
It's totally worth it.
Again, it's authored by Yimei Duan and Guotian, published in the Journal of Sports Science and Medicine. It's an incredibly rewarding read for anyone interested in the microscopic mechanics of human metabolism.
Make sure you follow the channel and turn on notifications so you never miss another customized deep dive into the science that literally shapes our lives.
Thanks for listening.
Because remember, the next time you step into the gym, you aren't just walking into a sweaty room full of heavy metal. You are stepping into the most sophisticated, highly customized pharmacy on Earth, and you hold a prescription. See you next time.